For days. We have Vivek and Amby presenting us some information about SONiC and OpenStack together, so looking forward to it.
Hello. Okay, so how many of you heard about SONiC as a network operating system? All right, so a lot of people, glad to know that. So here, it's myself, Vivek, and my co-founder is Amby, and it's a very new company. It's very young, so 2 months old, and last week I left my job and joined this company. And here what we are going to do is we are going to share some of the work that we did, part of the community initiative. What we did is we took OpenStack as an edge cloud, or a co-located data center, and we took a metal server, x86, and converted that as a L2 and L3 switching platform using SONiC and VPP as a data plane, and we were able to achieve multi-cloud connectivity to have a seamless connectivity between VMs running on OpenStack and the VMs on Azure and AWS. So that's a story that we are going to share now, what we did, and I'll walk you through the journey that we took. So before I go, so these are the community members. Me and Amby is there, and Tom, Julio, TRB, and Mitchell. So we are all the community contributors across the globe. And some of them sit in Latin America, some of them are from Europe, and I'm from India, and Tom is in US. He's from CA actually, he couldn't make it. Basically what we do is like, we have been contributing to various different projects across LFN. So starting from OneApp, OPNFE, Acrono Edge, that's part of the LFH initiative. And SONiC FIDO has been there for a very long time, you know that, right? So, and OpenStack. OpenStack I started in 2010 when I was with MLX, so that's where I got introduced with OpenStack, and Ironic was the first project that I was working on. And writing a BMC firmware which boosts the server from an iSCSI target. Okay. So that's the initial work I did. And basically it's a global team of contributors coming together. Okay. So what's the problem we were trying to solve, right? So, achieving real-time multi-cloud connectivity is not simple. It's a very complex problem. When you have compliance requirements to have your data and packets to be located in a particular region or particular metro, and nobody wants to do the networking job, right? It's if you look at it, right, everyone would love to become a full stack developer, right? Now everything is full stack or DevOps. If you ask anyone who wants to become a networking engineer, you will not see many people, right? That's a dirty job, I would say. Everyone thinks maybe. So again, achieving the low latency and data locality is also critical. Okay, so that's a very important aspect. So again, it's complex and expensive. Why it is expensive? Because multi-cloud is not simple, because you need to have a domain expertise from multiple different areas coming together to solve a problem, right? How many of you realized multi-cloud connectivity in real time or as a developer? Did you ever try that? Have you ever tried, any one of you? Because in any organization, if you go and ask that you have an ITIL process, you have different systems managing different infrastructure, right? Create a ticket, it may take you a day or it may even take you weeks to get to even realize the multi-cloud connectivity, right? So that's why the problem is more complex. So solution, how do we solve this problem then, right? So basically, it's again the mindset, right? So embracing open source is very critical, because we have very solid, proven blueprints available across multiple different open source projects. So that's also a challenge, right? You will not be able to find experts who even, can help you to set up things, because again, you have to be compliant with your internal ITIL process and other things come into play, right? So what we did is, this actually we did it for one of a customer who came to us for a problem to be solved. So that's when we started looking at it. And we took OpenStack and deployed it as an edge private cloud. And we took one bare metal server, x86 box, and then converted that as a switching, L2 and L3 switching layer with the data plane as a VPP. VPP itself can do everything today, right? So because VPP has got a data plane and it has got a control plane, is very complex there, because you have to go through the VPP CTL, and understanding those terminologies is a bit more complex. But when we combine the SONiC control plane with VPP as a data plane, right, that greatly simplifies the way we program the network or the configuring the network, because everyone is used to, right, in the networking world, you do config terminal, right, go to the config and then start typing your commands, right? Or you have a netconf, you push your configuration, right? So you have an Ansible playbook, push it, right? So that's where the SONiC came into play, okay? Because when we looked at it, the SI layer is so abstraction, such a way that it doesn't care whether is it actually making those API calls to an ASIC firmware or to a software library, right? That's pretty clean isolation layer, right? Switch abstraction interface, right? And that's the stack that we took it, and then we demonstrated multi-tenant and multi-cloud network connectivity using this platform. So again, so what is this use case is about, right? Let's look at this use case. The customer came up with the problem, like there are a large number of data sets, basically, satellite-based images, some drones doing some sonar scanning across the sea areas, they do some kind of lot of data analysis. Basically, these are all scientists who works on this field. So they came together, and then they have large amount of data that's spread across multiple cloud environment. Basically, various different reasons for that, because these are all funded by government agencies. So, but they would like to collate all the data in a particular edge data center, and then run and train their models, basically, okay, GPU-based servers. So this is where the problem started, because this is where the need of connecting multiple different clouds came together, right? So what we did is we proposed, using Equinix as a co-located data center, and they have metal, GPU, everything, but the infrastructure for this POC was 8 CPU with 225 gig GPS. These are all on-demand servers, right? So you don't need to have a capital investment. You can just hire per hour basis, right? So we recommended that, and Equinix shared fabric port again, because these co-located data centers, you have a variety of service providers and port providers, right? You can have a fixed one where you will procure the port for a year minimum, okay, and 10 gig or whatever the bandwidth you are looking for. But shared for this particular use case, the shared fabric port meets all our requirements, because from the latency point of view and the throughput, you won't see a difference between a shared and a dedicated one. Basically, it's the same fabric that Equinix is going to dedicate a port for you. But only difference is the port is dedicated, and you may have connectivity across multiple different metros. But in shared fabric, it will be only available in the particular metro, actually, because they're going to lease, time slice their free ports, right? When you have such a huge, massive data centers, right, you have a lot of switch ports sitting idle, doing nothing, right? And you get it almost like, I would say like 1/4 of the cost, and it is not something that going to have a huge capital for a year getting locked, right? So it's again pay per hour, actually. So monthly recurring charges again it will apply. And then we took West US as a cloud region between AWS and Azure, and SV as the Metro Equinix co-located data center that we took it. Basically, the experiment is to validate egress and ingress. Ingress, you know, almost kind of a zero when you push the data inside through a private connection to a cloud. But egress still costs you, right? When you move a data outside cloud, it costs you. If you go through the public, it'll be even more expensive, public network, right? So that's even more expensive. But here we were able to, you know, demonstrate the value. And solution is, again, we took the SONiC control plane and VPP as a data plane because we want to process the packet at the line rate, right? If you want to do that, you need a data plane like VPP. And again, we don't have a physical NAS here, right? We are not talking about hardware switches. We are talking about a x86 server acting as a switch because 25 gig port and with a lag configuration, you get essentially 50 gig speed actually. You should be able to process those packets, right? So again, we used Azure side for a private connectivity, express route, and AWS Direct Connect is what we used. And we used iPerf to test OpenStack VM to Azure VM, OpenStack to AWS VMs. That's what we did it. And again, AWS to Azure also part of the same network because now everything is talking to one single router. That's a SONiC, right? L2 and L3 is same, so they were able to, L3 basically, right? They were able to connect to each other. Okay, so what is the business value that we demonstrated? So basically, you know, if you talk about this entire solution, right? It is like you know, 1 PB of data in less than 48 hours that we could you know, transfer. Maybe physical switches could do much more, but here we are talking about the data that moves from node 1 to node 2, getting stored and be purchased because we don't have such a huge storage box. What we do, we just bunch of you know, files, we push it and then delete it. You know, there is an overhead in the packet headers. You know, a lot of things are calculated. So it's around you know 48. It's not exactly 48. It's much less than that. So that's a value that we demonstrated. Again, we took the blueprints from proven open source. Okay, look at the you know, maturity of OpenStack now. Right, it's almost 15 years now. I started in 2010. Now it's 2025. I'm here. This is my first conference scale, by the way. Okay. And again, on-demand and secure connections from edge to your public cloud because there's no cost commitment. Think about a use case where you have backup schedules. These circuits comes up, runs your backup, and tears down automatically because we used you know, readily available Terraform, Ansible, OpenTofu that you can readily use it, bring it up as part of your pipeline, backup pipeline, make the you know, circuit up and running and tear it down when you don't need it because you know, this is kind of a use case that one can look through. Again, significant cost savings. What we are talking about is huge in you know, egress cost we are talking about because when we go through, think about like you know, you have some data in S3, you have some data in Azure Object Store. You want to move this to your edge cloud run some training because you know, multi-cloud connectivity is not a fancy anymore, right? It's essential now, right? And especially in case of an IoT and AI, you can't simply depend on one single cloud service provider to give you everything because you don't have a matured model for your domain today. And I have a customer who came to me like, you know, I have huge set of scanned documents. Amby comes from an insurance background, actually. He has been working close to more than 16 years in the domain, right? You know the compliance requirements. They have a huge amount of data, right? And these guys say that, can you query all this, you know, 1 million files I have? I want to query that. There's no single tool right now. So what these companies are thinking is like, you know, why can't I use this file to train my own model so that I can query what I want, actually? Right? So those kind of use cases we are talking about in this. That's a business value that we demonstrated. This is a edge to multi-cloud connectivity topology. It's a simplified diagram, and everything comes on demand. And you know, for this demo, we experimented, how much will it cost me to do it, because I'm a very small company, right? So it's like two of us, right? Can I throw $100? Yes, yeah, we could do that. In $100, we could just bring up all this with a 50 Mbps line again, because we don't need 10 Gbps, right? So as long as you meet your latency requirements and throughput, you're good, right? Again, SharePoint and AWS Direct Connect, Azure Express Route, and everything is seamlessly able to connect to a L3, and they can exchange information. So, okay. So let's go through the demo video. Okay. Yeah. So if you look at it, so these are the two metal servers that we are talking about. These are the real metal servers. We brought it up on demand over Equinix platform. This is on the Silicon Valley that we brought it. And you can see the even the layer 2 VLAN connectivity as well. So we programmed it. Everything is on demand, programmable. We don't need to commit upfront costs. So everything is like pay per hour. Again, these servers comes with Mellanox and Intel cards. So, and some of them comes with Broadcom. I mean, the MLX card, that's a company I worked for previously. So, all these servers, you can boot it up, enable SRIOV, attach it to VPP, and then push your data through that, okay? So here, it's a private connection that we order between AWS Direct Connect. This is again a shared port. So it's an interconnect, they call it, and 50 Mbps. So there's no redundancy here because this is a very simple POC. We did it for this conference. So we have the Azure AWS Azure connectivity as well. And then the OpenStack is running on a metal server. So here we brought up a couple of VMs. And this is the topology that we are talking about. So we have the provider network. Basically, the provider network is towards SONiC. So that's what is going to connect you with Express Route and AWS Direct Connect, okay? So VM router comes up, and then we have VMs, which is connected to a tenant network. That's a private, right? That's local to your the OpenStack, neutral. So basically, yeah, give me a sec. Maybe I can fast forward this. Okay, so these are the VMs. Okay. So here you see that, right? So we have a provider network and tenant network. And the subnets that we have for the tenant and provider. And DR agent, basically, this is a BGP agent that we bring it up, okay? And there's a speaker which is getting connected towards your OpenStack tenant network and the provider network. Basically, you need to have two interfaces, right? So that's what the BGP speaker. So this will have the next hop as 141. That is the IP address that will be used from the SONiC. Okay. So this is a router configuration that you will have. It will have two arms, basically one towards private, I mean the tenant network, and one towards the provider side of it. So this is a SONiC control plane configuration, right? So basically, now this shows all the network interface configurations and the BGP that we need to enable between Azure Express Route and AWS Direct Connect, actually. So basically, this control plane internally uses FRR, right? These are the interfaces. You can see there are three interfaces, one towards OpenStack, one towards Azure. The second one is to 47 is towards Azure, and 168.47, 168.510, and 174 is AWS, actually. So Okay, this is your BGP summary. Basically, you can see those paths, right? So who are the neighbors? One is from the private subnet, I mean the BGP speaker from OpenStack. One is from AWS, one is from on the Azure side. So this is the express route configurations. So again, this is again West US. We picked it up. The reason behind this is like, why we picked up, because the shared ports doesn't allow you to connect to a different region, because if you have a dedicated ports, Equinix allows you to connect different regions. If you have shared ports, they only allow you to connect to the region which is closer in the proximity. I mean, you have to connect it to SV means West US, you should be able to connect all the data center. It's just not AWS. They have Oracle, they have everything actually. Whoever worked in, I don't know how many of you are aware of Equinix? Well, many, right? So you should be knowing this, right? So basically, shared port has got certain limitation, but if you have a dedicated port, yeah, of course, you should be able to connect anywhere. Even between the metros, you should be able to connect. Even if you don't have that, you can have a backdoor connectivity. They have a separate backdoor network that you can configure between those edge locations. You should be able to, connect as well. So, see. This is a gateway that I don't want to get into that. So Azure is a bit more complex, I would say, like some of the configurations. But again, this is a direct connect. Again, this is also the BGP, that they bring it up at the Azure side. And you can see that, it's already paired with the SONiC switch. This is 174 subnet. And you can see those virtual interfaces already started showing some traffic. And the beauty of SONiC is like SONiC comes with a lot of those monitoring capabilities, right? You can do an open telemetry export and push it inside your Grafana to see a real-time graphics, right? So that's what we will be doing here. And if you see here, right, the round trip, right, delay between the Azure and the OpenStack VM, right? The VM is, demo VM is nothing but OpenStack. And you're pinging the express route, you can see the latency. The round trip time is 148, which is to and fro. You get an echo, right? So that's why you see that it's off of it is less than a millisecond that we are talking about. Okay, so if you have a low latency applications, which needs to grab data from multiple different cloud infrastructure, this fits a bill because it's cheaper. AWS Direct, you will see the similar numbers. Okay, so now we are going to run some hyperf tests between OpenStack to AWS VM. So these numbers, because we ordered a shared port of 50 Mbps, right? We almost saturated with this. So essentially, there's no much of difference between a shared port and the dedicated port. We were able to match exactly the same results. So this is again the Prometheus export of OpenTelemetry from SONiC, and we could real-time monitor from an operation standpoint, and you should be in a position to see what's going on in your network, right? So that's what, again, this is about OpenStack VM to Azure. Again, you'll hit 50 Mbps. That's a shared port that we ordered. Okay, so the next one is so now the VM from AWS and Azure should be able to talk to each other, right? So that's a test that's getting started here. So basically, you can see that, right? Again, it's heading close to the 50 Mbps. So both the sides we are able to meet. So that's pretty much the part of the demo. So what is the immediate focus that as a small startup that we are going to focus? So the area which is interesting for us is storage, right? So because Cinder has been there for a very long time, it's quite matured and a lot of provider drivers readily available, right? Chef and Pure and if you talk about NetApp, a lot of these storage providers are there. So what we are thinking is like use the SONiC VPP as a data plane and then demonstrate a cloud adjacent storage. Right? How could I have a storage at the edge and expose it to multiple different clouds? Why should I do that? Right? You may ask the question because, if you look at it as from the Spot instance point of view, right? If you have entire storage in Azure, you can only consume that storage within the Spot instances coming up because you save more than 50 to 60% cost if you go with the Spot instance, especially in case of GPUs, right? It's damn expensive, right? Think about it, right? You move the storage to the edge and make those Spot instances comes up and goes down because you don't need to worry about the state of the storage, right? And you keep pushing things back to the edge, storage at the edge. So that's one. The second one is SONiC with VPP MEMIF. Why do we want to do that? Because the work what we did is quite matured from the SRAV point of view. But if you want to chain the functions, network functions, right? It's always better to use a MEMIF actually. So that's what we are going to, this is planned for Q3. This is actual development work that we are working on. Again, what are we looking from this conference is to share the knowledge that we have. So that's the idea behind this because, community, open source community is nothing but like, you learn a lot from the community, you contribute back to the community, you share and you grow. So that's the idea behind this. So that's again, and we specialize in certain, open source projects. We have taken some of the proven blueprints and implemented in production. One of a Latin American telco, we took some of the project components that I talked about, one app, and we implemented the entire MPLS, network discovery and automation, close to 20,000 devices. Today it is running in production. The same set of teams were part of that project engagement actually. So it's huge actually. So apart from that, right, again, GPU as a service using OpenStack just before me, the metal, Open Metal was talking about it. And we are pretty open for any training or workshops if somebody wants to experiment the multi-cloud connectivity, all right? So that's pretty much we have. And any questions? Oh yeah, go ahead. For Equinix? Yeah, pay-per use. Yeah, because everything is charged per hour actually, right? But Azure does differently because what they do is if you bring up an express circuit, right, they don't charge you, but the moment you connect, the billing starts. Because the port charges because they have to reserve a port on their side, right? And Equinix charges from the fabric connection point of view. So that's when the billing starts actually. Creating express route doesn't cost you. But the moment the circuit becomes active, they start charging you. Yeah. 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 Thank you. Yeah, Megaport, yeah. Correct. Exactly. So that's the cost benefit that, I said, right? $100 one should be able to experiment. If anyone is interested, please reach out to us. We will help you to do that. Okay, so we have all these Terraform plans, Ansible scripts. You should be able to quickly experiment if you have an account with your Equinix. Otherwise, we can even, work out something to share our account as well. So as long as we recover our costs, we are good. All right, thank you.